All right, let's get going for today. We are at Wednesday. We're going to be doing some more forensic serology, which is testing of fluids. We're going to learn some serology test techniques and purposes and learn how to collect today. And then next time we're actually going to do a lab where we're actually going to collect and then test kind of thing and try and then determine the blood type. So you're going to use everything that we've done so far. And then the next time we're going to go into a little bit of DNA. We're going to hit that harder if we have time later. But if you like DNA stuff, that's more biotechnology, and you can hit into the biotechnology. All right, so going into blood origin testing. This is sort of like a pedigree, and they can tell if you belong within a family tree. So if you grab your notes out, we'll get started here. This is, like we talked about last time, where our presumptive tests were blood typing. Last time we could say, yes, this is a possible father, or no, this is not. This becomes even more precise. Okay, blood testing origins basically come into two categories of tests that are available for investigators. You need to know the difference. So presumptive tests are used to quickly determine if I've got blood on the scene. So is this substance blood? Is it just red paint? Is it ketchup? This will let me know. A presumptive test turns really quickly at the scene, and I can tell if it's blood. Confirmatory tests have to be done in the lab, and these are tests that give me much more accurate results. I can tell a lot more about the test itself, and DNA would be in that confirmatory test. So presumptive just lets me know in the field, is it blood or is it ketchup or whatever. Okay? Okay to go on? Everybody's got a definition for each of these? All right, so when we do blood origin testing, two categories of presumptive tests are color changing tests that change when I touch it with something, and those are luminol, benzidine, phenolphthalein, which is Hasselmeyer is another test name for the phenolphthalein, TMB, and hemostat. Those are color changing tests. The other are glowing reaction tests of fluorescein. So looking at a floor, I don't see anything, but if I spray this on and put it on a black light, I can see that there's been blood there, kind of thing. So those are the types of tests we're going to be talking about and going into. Okay, so the first one is the phenolphthalein presumptive test. This is also known as the Kastle-Meyer test. You'll need to know that for the test. So it's basically just using, if you've ever had chemistry, phenolphthalein. And the phenolphthalein will turn pink in a base. And if we put a little bit of hydrogen peroxide on a blood sample, then it will turn it pink when we put phenolphthalein in it. So in the presence of hemoglobin, phenolphthalein will turn pink if it's been treated with hydrogen peroxide. Phenolphthalein reagents can give false positive, especially when vegetable material is present. So if something has vegetable stuff in it, and specific vegetables we won't go into, but there's specific vegetables that if they're present, it will tell me that it is blood. But when I get back to the lab and do a further test, it'll show no, that's not. But it is a bright pink test and very easy to see. Okay, to go forward, you need a few more seconds. Okay, another one is known as a TMB or hemostat presumptive test. It's sort of like the dip test that you see at the doctor's office when they do in the urine. But this test is just performed by plastic steps. You test the swab by moistening it with some water and placing it in contact with the stain. And then the swab is placed on to the tip of the strip, and you just compare it to something on the side and say yes it is or no it's not. Basically though, if the hemostat turns green, then you've got blood. If it stays yellow, you probably don't. Very easy. And this one says it's for urinalysis. It's just testing for blood in the urine, but it does the same thing for blood in contact with anything else. Okay, next one is the luminol. The luminol tests for latent blood stains. It can detect up to blood that's been diluted 1 to 10 million times. When luminol and hydrogen peroxide are applied to a blood stain, the luminol produces the blue, yellow to white, yellow, green light, depending on what luminol you're using. And it can affect some testing processes, but does not affect most blood typing or DNA analysis. So we can still determine blood type, and we still could do DNA on it. We just want to see where it's at, kind of thing. It produces a false positive with some plant enzymes and oxidizers, metals and chlorine. So there is some problem things that you need to be careful of, and you need to know your limits there. Too fast, let me know. Next one is a fluorescein. Fluorescein tests also for latent blood stains by fluorescing under ultraviolet light, so you have to have the ultraviolet light. It can detect blood stains that have been cleaned with solvents such as bleach. So if somebody's tried to clean up the area with bleach because it makes it look nice and clean, you can still see where the blood has been. Fluorescein can also be applied to vertical surfaces, unlike luminol. Luminol does not stick to vertical surfaces, it just runs. So if you have any vertical surfaces, you want to use fluorine. And copper and hypochlorite will also cause a false positive, so you have to be really careful. Which is interesting that they said it can be cleaned with such solvents like bleach, but then it can give a false positive because bleach is hypochlorite. So, all right, so here's a summary of the tests that we talked about. What their indication is, what a positive, when their situation, where they would be used, and when do I get false positives. And I've gone into a little bit more explanation on the false positives here. So I think this is, you actually have to copy this down, am I right? Well, that is actually already done for you. It's backwards here. I don't know why. It's right here. Do you see that? So there's just a few things that you need to fill in right there. Got some of you are staying with me. So it's actually right here too. All right. Sorry, I must have got some of these out of order a little bit, maybe. No. That's right. Okay, so these are all the presumptive tests. These are the ones that we would do out on the site when we have a crime scene, and to determine if we have blood that is at the crime scene that we need to deal with, whether with testing or with blood spatter, which we're going to be going into. Remind me to put up you've got to make some fake blood, so I've got to give you a recipe. And that needs to be coming in the next day or two. So, with your name in a little jar or water bottle, kind of thing. Because you get to make some blood spatter. doing. While you're doing that, I do need some help tonight if anybody is available. It's first night, we bring all sophomores in, and I will give you a little bit extra credit. I don't know how much, but I'll figure it out. And I've got 3 areas that I'm in charge of. Medical forensics. I'm going to have them try having you fingerprint them. They don't get a fingerprint. You would have them fingerprinting them, so that would be help there. And then I'm going to have chemistry. If you are a junior or a sophomore and you haven't had any of it, this is a good one for senior because you get a job shadow at the very end of the year in the spring, and then you get a guaranteed job interview. And if they like you, you start between $20 and $25 an hour, and they do tuition reimbursement, which is amazing. And then this class right here, you just learn techniques like how to do DNA, how to do electrophoresis, how to use the pipettes, how to, all the lab equipment, the microscopes and the autoclaves and all that kind of stuff. So if you're interested, this is awesome. Also, if you're interested in stuff like this summer down at the U of U Huntsman Center, it's on the edge of that table back there, they've actually got a thing you can submit to go and be part of the Huntsman Center in lab. And they will pay for your room and board up on campus. You get to be in lab, shadow somebody in lab, and they pay you $3,000 and give you a chance to win a $1,000 scholarship to the U. So awesome there, awesome here. Anyway, we're doing all those tonight. So if you want to come help, let's have a sign up when you get there that you're there and how long you're there, and then I'll decide how I do points for extra credit. So that's an opportunity. Okay, everybody ready to move on? I was sort of jabbering for a minute to give us some time. All right. So, blood origin tests. So, once a stain has been characterized as blood through a presumptive test, it's collected and stored for a confirmatory test. The 2 most common confirmatory tests are I cannot say these aloud.
Takayama.
Thank you. And the Teichmann test. And these are both where you add things and you look at it under the microscope. So the Takayama, you can see it makes more like a feathery-like thing coming out, where the Teichmann does little, it doesn't clump, and it's very, almost looks like wheat shafts that have been, sort of shaved up, where this one to me looks like more like feathers. So let's talk about each one individually. So the Takayama, I'm going to go with your saying of it, is performed by adding alkaline, which is base, solution to a specific structure of hemoglobin to the stain on the microscope slide. So if the blood is present, pink crystals will be observed as the slide is heated. So usually heat a slide to fix whatever you got on it to that, and you get these feathery-like crystals for the Takayama. For the Teichmann, you see that it's a lot different look underneath the microscope. It's done by adding a small amount of chloride containing acetic acid. So that would be like acetyl chloride, anything like that you add to it, to the blood sample under the microscope. And these small little crystals form on a slide if it's heated and blood is present. Once the stain is confirmed as blood, it must be tested to determine the source, if the source is human and animal. And we saw what the difference between human and animal were last time in the slides that we were watching. Okay, any questions here? Need a minute more, or are we okay? All right, so another blood origin test that can be done, this is usually where we have a lot more blood that we can play with, is a precipitin test, and it determines if the stain is of human or animal origin, and it uses rabbit, serum made from rabbit, containing antibodies against human blood, and when you mix the two, you end up with this white precipitate in the center because it starts to fight each other. So the crime scene blood is usually laid on top of the anti-human anti-serum in the test tube, and if the sample is positive, then a cloudy precipitate will form. Now, if I've got a lot of blood, the crime scene is really easy to do. If I don't have a lot of blood and I'm not sure I would do this, I could use some of the blood diluted in some distilled water and then put it in. Hope I get that cloudy layer by using just a small amount. But you can see that's a pretty, and if it's not a really tiny test tube, that's a lot of blood. Okay, so the presumptive, you get the white layer between the rabbit antibodies and the human blood, which is on top. We know about antibodies and antigens, right? Antigens are on the red blood cell, antibodies are in the plasma. And this is the human blood, and this is the rabbit blood on the bottom. Rabbit serum, I should say. Lovely. Okay, you okay to go forward, or you need a few minutes? Okay, we're going to watch this video really quickly.
For this experiment, you will need to wear gloves and goggles. Open a sterile cotton swab. Retrieve a dried blood strip from the glass jar. Add a drop of distilled water to the cotton swab. Make sure that the swab is wet all the way around so that you can pick up a good sample. If necessary, add a second drop of water. Roll the moist swab lightly over the blood strip. Next, add a drop of ethyl alcohol to the swab. After adding the ethyl alcohol, add a drop of phenolphthalein to the swab. Lastly, add a drop of hydrogen peroxide to the swab. Shown here is a positive test result. In a positive test result, the swab will turn pink.
Okay, so that's a Kastle-Meyer test.
Shown here are positive and negative test results. The blood strip that we tested was a positive control. Since it contained hemoglobin, we expected it to turn pink when hydrogen peroxide was added. If we test another sample that does not contain hemoglobin, the swab should not turn pink. You must test positive and negative control samples before testing any unknown samples to ensure that your reagents are working properly and that you are following the test procedure correctly.
Okay, so you do have to test a positive and a negative, and then you can test the sample. And that's just to make sure that your reagents are good. Okay, and there's nothing contamination going on. Okay, we just did that. Okay, so if you get back up on your daily thing, There is a link for you that I'd like you to take and go to right now. It's Serology Test Techniques and Purposes. You just click on it, and then there's two things I'd like you to watch. And then I want you to quickly summarize in a text box, so you get points. Give its name of the test, what it's used for, and why it's used in the text box. Okay, so you're going to just summarize each of them in this. All right, if you want to have a Word document off to the side and you're sort of filling it in as you go and then just copy and paste it in the text box, that's awesome. There are headphones over there. You might need them. Okay, and we'll go back to this real quick. I think that's the end of no. So I'm going to give you a few minutes to do that. Hopefully we'll get some sound here going away in just a minute, and then we'll come back about 15 after. Okay, it shouldn't take that long to do this. What are they doing? I have no idea. But they're noisy, aren't they?